finally we come to the JIT class. And as we mentioned, the JIT class likes Python class or Python class. It helps us to pack different attributes and functions in a single object. And the basic syntax of JIT class is we need to pass a list of the attributes into our JIT class decorator. And here we should mention that here the int64 and this float 64 should be imported from number, and the JIT class should imported from number.experimental because currently it is still an experimental feature. And then we just write the function just like the normal Python class. So what we should notice, all the functions in JIT class should be valid under no Python mode. If we have a Python series, so it will not work. So let's try. We first pass integer 1 into our class and an array into our class. Then we combine, where the combine operation is do the multiply and sum all the values that is equals to 4. So that is the basic syntax. And then we will do a linear regression example. And here we have our self.w and self.b, that is the trainable parameter in our linear regression. So this is mainly come from the gradient descent algorithm. So what we should pass is what we should store is a scalar w and a scalar b. They are both float 64. And when we do the fit operation, we need to pass our x and pass our y and then the learning rate and the epoch. And also we need to construct to make a function that return our training results. And just like the scikit-learn, we initialize our function by constructed a linear regressor object. And our w and b true value is 1.5 and 100, 200. And we'll construct a random variable here. And we fit our variable here. And finally, we get our predict w and b. We can find that it's very close to our true value. So our function can be called accurately. And this is very convenient, and because if you write Python, you have to write very annoying type annotation. Also, the compile process is complicated. Maybe this the function, not the function, the feature of JIT class is limited. So if you need some advanced modularization steps, you should still need Python, not the JIT class. If you want a simple class, you can just use it. So finally, I will have several tips for you, especially they are very useful when you are do the data processing on large data set. The first is you should only use non-Python mode, because if you failed in non-Python mode and if you use the Python mode, then it will not accelerate too much. And the second is, although the the number support a list operation, but maybe you should never use it because list operation in number, including the append operation or pop operation, they are both slow. You should use if you know the longest or the largest size of your container, you should construct it in the first step, and then using the index to change the value. And you should write more for loops and use more array indexing. They are very fast actually in NumPy. Although for loops is very slow in Python, so you should change your mind in NumPy. And the fourth tip is please check the reference I just mentioned in what are valid in the non-Python mode, and what can be parallelized in the P range. They are very important. If you do not know, you may make mistakes or the code will raise error. And fifth tip is think about your data structure. If you need indeed need some very not very complicated, some data structures that are not supported by Numba, such as you need some queue or some stacks. They may not supported very well by Numba. You still need to use Python with C++. And the last word is to carefully benchmark your code. That is very important because it will tell you how much you have done on the performance enhancement. So these are very important tips on for different kinds of situation when you use Numba. Okay, this is the whole contents for the Numba extension. See you in next lecture.